Yeah, good morning, or yeah, it's still good morning here. My name is Henrik Christiansen. As you can see up there, I'm the president of Graphic Robotics, and we have focused on robots. And you can see from the companies here I work with, I'm an offset guy, yeah, in a digital world here. I started with robots roughly 10 years ago, so you can see today I don't really care about offset, flex, or digital as long as there's sheets to be moved. We care about kilos. I can start with the first question out to the public here. What is a robot? Anybody knows what a robot is? You know it, all of you, but what is the definition? Okay. 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 I will start here. There should be a video here, but next. This is a robot. So the definition is that it is a manipulator, that's a blue one, which can be programmed to move in more than 3 directions. And that means being programmed, it has a brain also. It's a computer, it's a brain, and that's where the things are happening now, because with the exponential growth in memories, the robots can do much more. A typical robot has 4, 6, or 7 axes. If we put them into a robot cell, they will have much more. Let's see. Mobile robots, they don't really follow the definition, but they are also programmable and they can run. And the left one is a mobile robot, the right one is an AGV. And in my opinion, where the Schnitzel in German, where the differences between AGVs and mobile robots, it's not really defined. So my personal definition is if they have forks, they're AGVs. If they don't have forks, they're mobile robots. Somebody would say it's a navigation system. This AGV is running on a Kollmorgen laser scanner system, which is a little bit old-fashioned. All the mobile robots have autonomous navigation systems, but you can put autonomous navigation systems on AGVs also. So, robot. The name comes from this Czech writer, Kapek. He wanted to make a book show, and he didn't. It was about artificial persons, androids or avatars. And he asked his brother, what shall I call them? And in the Czech language, artificial labors are robota. So that's how it all started. The first robot was really introduced in 1960. It was developed in 1954, and it was running for a GM plant in Trenton for many, many years, moving hot items. It was this George DeVol who developed it, and he wanted to make a science fiction book, but ended up making a robot. So this is one of my, how shall we say, hard things. Everybody is saying robots are taking away labor or substituting labor. So at the end of the day, nobody will have anything to do. I've just taken some examples here. You can see Stone Age hammer. Everything is about improving human productivity, and a robot is, at the end of the day, just a tool, like anything else. Up there is, by the way, the first printing press for Frederick Koenig, and that also increased the productivity of humans quite a lot. You have self-running farming equipment. You can say they're also robots at the end of the day. I took this here because if you say programmer, you would also say unmanned. And this robot line is unmanned, and you can see the protection outside, because the robots, the normal robots, industrial robots, are moving a lot of kilos, and that means it's a little bit dangerous to be close to them. I took this specific picture because that's a factory up in the middle of Sweden making furniture. They are a subcontractor for IKEA and has been one of the first subcontractors for IKEA. And I think you are all familiar with IKEA and their simple products. And one of the simplest products is the Billy bookshelf. And that is produced very profitable in Sweden. I would have thought it was in a low labor country, but it's produced in a high labor cost country, very profitable with robots. They have around 100 robots. You get the plywood in from trucks in one end and the finished bookshelves out in the other end. And here there should be a video. There's no video here, but just to say, this is a new thing, collaborative robots, and that means the protection has gone. So you can have an operator and a robot working in the same environment. Of course, the problem here is that you have to be very careful with the safety of the robot, and just now the robots cannot handle many kilos and they are slow. And you could of course also say if you have a cobot, collaborative robot, which can take say up to 10 kilos now, and it can work without a shelf or protection, it depends a little bit what you put on as tool. If you put a samurai sword on the tool, it will require protection anyway, yeah? And it's just to say, these are the 4 big manufacturers of robots, Fanuc, Yaskawa, ABB, and KUKA. And you can see on the turnovers how big they are. Robots are basically stupid. They have a brain, but it's an empty brain. Eh? So then you need a system integrator to put something into the brain. And for the graphics, that's where we are operating. We will act as a kind of system integrator. So we take the Yaskawa robot and we put it into, here it's a sheet cutter line. And this is what the system integrator does. And there's a lot of system integrators out in the field. Not so many in graphics, but in normal applications. So now I will go more to direction print and robots. But before, I'll just say 60% of all robots today are in the automotive industry. And of new sold robots is between 40 and 50% going into that industry also. The printing industry is 30% bigger and has nearly no robots. So we can say half empty, half full glass. We think it's a fantastic opportunity to go into the printing business because there are nearly no robots. Robots in the printing, also other places, but in the printing will eliminate the heavy, dirty, unhealthy jobs. And this is of course very good for your operator health. We will also eliminate the human lifting capacity, and we think that's a real bottleneck in the printing industry. A lot of the products in finishing are, the machines are extremely automatic, but the sheets are fed into the machines and the sheets or the folded products are taken manually off the machine. So eliminating the human lifting capacity, we would say robots with roughly triple to 4 times the production capacity. So yeah, robots will give you more production capacity. More production capacity and less labor means more productivity and lower unit cost, with one condition, as long as you can sell the capacity. If you change from a flexible cost of an operator to a fixed cost of a robot and you don't sell the capacity, then you get increased unit costs. So you have to consider. Then we can say robots can work 24/7, so can operators, but the difference is that the robots will be cheaper and cheaper per hour if you want 24/7, and the operators will get more and more expensive because they need night and shift added to them. We can also say as a little special point, theoretically the robots could work in dark rooms, so you could also eliminate cost for electricity for lighting up the rooms. So at the end of the day, the robots will take away the stupid, heavy works that the operators don't want to do, and we will allow the operators to concentrate on the works where they can use their skills to improve productivity. So, where can we put robots into the printing industry? And we would say we could basically put them in nearly all places if there's creativity enough in the thinking. We heard about the guy this morning about creativity. But we would say we could put robots into the paper storage. We can add some robots to the printing presses. We can add robots to sheet cutter lines, folding lines, saddle stitchers, die cutters if you go into packaging, folder gluers, whatever. I wouldn't call it our problem, but our problem is it costs a lot of money to develop a new application, and the printers don't want to pay for developing products. They want to pay for the finished product. So to get more robots into the printing industry, we need a collaboration with what we call the OEMs, the manufacturers of printing press or finishing equipment. And we have several agreements with such companies coming up now. The reason there are not so many robots in the printing industry, I forgot to say two things. Simple robots, that's handling robots. More complicated robots going into the production processes will be process robots. So you will see robots in the printing industry and other industries palletizing boxes from one to the other. This is a very simple exercise. As soon as you go into the production processes, it will be complicated. So especially in printing, we have some real challenges. One is that we are handling flexible materials. If you look about what robots normally do, they're moving a box or something here with a fixed size, but paper is complicated. I think you're all working with paper, so you know that paper behaves strangely from time to time. I don't know if you can see it, but we call it easily as and seagull wings and its waves on the piles. The robot has to detect these things to be able to work with them. Our solution to that is we go from a conventional single-arm robot to dual-arm robots. This makes the process of handling flexible materials much easier. Then we have another challenge, also special, I wouldn't say special, but mainly special to printing. We are running small orders, we are running ever-changing orders, and a lot of new jobs, because even a reproduction of an existing job will be a new job, because you might have changed the humidity in the shop, you might have changed the inks, and so on. So we are faced with a lot of new jobs. And as the definition is, the robot has to be programmed, but we cannot program something which we don't know. And this is the real challenge here. We have had same job, same plates, same inks, same press room, same dampening water. This is a Komori and a KBA. The results coming out are different. The operator will know it by his spine or by finger touch. This is different. It's the same job, but it's acting different. But the robot stops if it gets another job. So therefore, we are saying it might look the same, but it could be different products. So we can also see down through the pile, sometimes we get changes because there has been higher pressure on the lower sheets than the upper sheets, and that will also give a change. So our solution is to say we are making collaborative robot cells. That means that we have the robot handling the difficult, heavy jobs. We have some templates how the robot is running, but we will let the operator give his impact to how much do I want to twist the sheets, how big rims do I want to take. He can do a lot of exercises based on his experience. So we are also saying our robots or our robot solutions, and we think that's general for complicated print jobs, cannot work without skilled operators. The operator will be able to do much more than he did before, that is increased productivity, but we cannot eliminate the operator and his skill. At least that's where we are now. And there would have been a video showing the touchscreen in function. Next step is, normally when I come out to customers, they are saying, okay, we want to robotize this here, but we don't want to hear about your very expensive robots. We want a simple, cheap robot which we can just program to doing this and that. And our reply is to that is, if the application is complicated, the solution will be complicated. You cannot make a complicated application work with a simple robot programmed via your iPad. The company there is a Danish company called Universal, based in Odense. We are based in Odense. There will be other products based in Odense. Universal Robot is market leader in cobots. We meet them all the time. They cannot do the complicated applications. They can do the simple applications. And that's our dual-arm Yaskawa robot. And also another thing, what is easy for a human being can be difficult for a robot, and vice versa. And there are many examples for that, but you can take it here. We can easily ask the robot to pick all the oranges out of a basket. That an operator can also do. We can ask the robot to pick oranges, which has a diameter of 9 centimeter or 9.5 or what. Put these in various boxes. That will be a difficult task for the operator. We can ask the operator to pick the, what do you say, the dirty, the faulty oranges out of the box. We cannot make the robot pick the faulty oranges out of the box, because then we have to define what is a faulty orange, and that's difficult to define. Yeah, this is also a video. Huh? So this should show, some years ago, we made an application for palletizing books. This is hardcover books, and this is a simple palletizing exercise. And perhaps it functions. Okay. Any questions till now? To use the spare time here? No? Have any of you experience with robots in your plants? No. This I don't know, honestly, but few. But there are many robots installed in the finishing department's palletizing. And there are also several packaging companies running mobile robots in the finishing end, packaging end. No, not packaging, the delivery end of their production lines. The challenge starts where we are working in the process robots. Yeah, well, now it functions, okay. It's just to say that's a rather simple palletizing exercise. And we have a little bit less noise. Oh, what happens now? Can I go to the next one? So you need to stand there all the time, huh? This is a video. No? You all know that, I think, if you're familiar with commercial printing. That's a guy moving the sheets from the pile to the vibration table. Let's see. Does the next run? No. This video would show how we do it with a robot in this company's typographic. So now it starts to be a little bit complicated because the presentation was made around the videos. Folding machines. This is also a video showing a normal folding machine. The feedback we get is that the pallet feeding of the folding machine is complicated. You have a lot of stops because the more ink you have on the sheets, the more the sheets tend to stick together. So the best feeder for a folding machine is what they call in German a Rundstapler, a continuous feeder where you can put on the sheets in stacks and you can shinkling them in, is it English? You can lay your sheet out so you can take the sheets one by one. The continuous feeder can change from job A to job B in nearly no time, and it can also run non-stop. So it's a much better feeder. And the next video would show how a continuous feeder functions. The video is not running. And then we would show you how we can do the continuous feeder with a robot, but doesn't run. Next video, we have a close collaboration with MBO in Germany. Next video would show you how MBO has a simple robot from Universal at the delivery. With the other run. Yeah, let's go on back then. This? No. Will this here run? No? Will this? Yeah. It's just to say you have a pallet in feed, which is complicated, and you have a guy standing there palletizing the stuff. And I think you're all familiar with that. This guy there, he would then feed. So this is a much better feeder, but it's manual. So nobody wants this here because you have the heavy manual work doing like this. So, and then we will do it with a robot. It's a test, and we know we are too slow, but just to see what we are doing. And the objective from MBO and us is that at Drupa 2020, in 12 months, we will have such a robot feeding 2 folding machines parallel, and there will be one of MBO's own robots behind each of the folding machines. So we would have 2 folding machines running around 15,000 impressions per hour, or sheets per hour. They calculate in meters per minute in folding machines. But we will have such 2 machines running parallel with one operator. That is 30,000 sheets, one operator. And the typical production today is 8,500 sheets per one operator. So we have tried to copy what the guy is doing there, and it's a complicated exercise this year. And we will do several modifications to this setup before Drupa, but that will be the objective. Oh. Also run. This is MBO's new introduction a month ago. This is a conventional MBO folding machine, and at the back end you have a simple universal robot, palletizing. What we would like to do, I said we can feed 2 folding machines parallel with one robot. We can also feed 2 sheet cutters parallel. From our side, it would be very interesting to feed, as we are trying to sketch here. We haven't done it, but we can do it. 1 folding machine and 1 sheet cutter with the same robot. The reason being, in marketing, we can say, if you think about the market as a triangle, we require a lot of production volume to have the robots, and that'll be up in the top of the triangle. If we can run 1 folding machine and 1 sheet cutter parallel, the volume requirement from the customers will be lower. And this is a little bit dreaming here. What we would like to do, we would like to feed the feeder stations of the saddle stitch or collators. And we would also like to feed the horizon. So if you can imagine in digital, if you feed the horizon there and you have a robot on the delivery side also, it's a very interesting exercise. The problem from our side feeding okay. Somebody tried some years ago with a single arm robot to feed the magazines like the stitch liner. And it doesn't function. We think it requires a much more sophisticated solution here. I will get back to this in a moment, this slide, but I would say our problem with feeding the saddle stitcher is not feeding the saddle stitcher. Our problem is to get the products from the pallet before the saddle stitcher, that is the pallet after the folding machine. And the way MBO delivers the signatures on the pallet, we cannot get them with a robot next step. it has to be manual. So to be able to feed the saddle stitcher, we have to come up with another solution for palletizing after a folding machine. I don't know Swiss Q, but I was contacted by a Swedish company, one of the biggest Swedish printers, 14 days ago, and they said, couldn't you come and tell about your robots for our big inkjet printer? And I said, yeah, but Swiss Print has a solution with a universal robot. And he said, yeah, that's very good, but either the robot solution is wrong or our buying of this big inkjet printer is wrong, because you have a robot which can feed half a square meter, 3/4 of a square meter sheets, but our table is 6 square meters. So we want a robot which can feed everything. So you can say this is a question about you have to be very careful thinking if you're doing some robot applications that the application fulfills what you really want to do. Will this run? No, it's the internet. It will not run. This is Kongsberg. Kongsberg has a big robot feeding their cutter tables. And this is also an interesting application. They have a very big gripper with suctions, which can feed the table. Our experience related to suckers is that we have talked a lot with Agfa in relation to the Annapurnas. What happens there? Okay. Doesn't really run as it should, but its thing is to say they have made a very, very big gripper with suction to be able to feed that table. And that's a good way of going. It's just that we have talked with Agfa related to Annapurnas, and we have talked with Agfa related to feeding plates into the CTP. And we hear constantly, don't use suckers, because if you use suckers, you have to use one type of sucker for one material, another type of sucker for another material, and you will get marking on the substrates. So we are not real big suction friends, or sucker lifter friends. We would probably do it in another way. Another thing with these two solutions for inkjet printers and for cutting tables is that, what if you want to print on both sides? How would you make the robot turn the sheet? We don't think they can do that. But again, we are all trying here, and it's just to say that we have to think very carefully through what we want to do, what the solution should be. Now we move into internal transportation also, because the run lengths in sheet fed printing is going down, very much down. So many printers are down to 1,000 copies or less per job. You can do, at least some printers can print several jobs on the same pile, but some prefers to print pile by pile. And if you go from 10,000 in a job to 1,000 in a job, you will tenfold your number of pallets. That means you will have a lot of more transportation of pallets in there. So, can that run? That was our try in Drupal 2012 to put a conventional AGV together with a robot. We were standing on Torai's stand there. I love Torai, but nobody really loves Torai plates. But we decided we wanted to put an AGV. That was before the time of the mobile robots. We wanted to put an AGV in the system and run it into the delivery of the KBA. And we really thought KBA would go crazy when we did this here, but they accepted it. So we ran with a pallet there and moved it to and fro. I was very surprised that after Drupal, very few people were interested in this here. I would say the payback in mobile robots or AGVs is even higher than putting robots on the various machines. Stop. Yeah. And this is also Odense. This is mobile robots. There are many manufacturers, several in the United States, but this is mobile robot solutions. Can we run the video from the internet?
Have you ever wondered if there was a way you could optimize your internal logistics flow? At Mir, we offer flexible, user-friendly automation of any internal transportation task. And when it comes to heavy-duty operations, our autonomous mobile robots, Mir 500 and Mir 1000, will revolutionize your internal logistics. The Mir 500 and Mir 1000 offer a safe alternative to traditional pallet lifters, allowing for a hassle-free, fully automated logistics workflow, saving you both time and money. The Mir 500 can carry payloads weighing up to 500 kilos, and the Mir 1000 can transport payloads up to an astonishing 1,000 kilos. With the optional pallet lifts from Mir, you can easily pick up, transport, and deliver EU pallets and other pallets onto pallet stations, ensuring smooth and seamless transportation to the destination. As with all our robots, the Mir 500 and Mir 1000 are collaborative, with multiple built-in safety features, including dynamic safe zone monitoring. The Mir 500 and Mir 1000 always maintain a safe distance to employees and obstacles. The robots can cover long distances, making them a perfect fit even if you have a larger factory layout. When its battery is low, the robot automatically navigates to the nearest Mir charging station. Everything is handled in real time by the Mir fleet management software. This means that the entire range of Mir robots can be controlled by the same fleet and used at the same time. The flexible robots can be redeployed for different tasks by changing the top module, which allows you to transport a wide variety of items. Get in touch with us today and learn more about how we can help make your item transportation easy, fast, and reliable. Mir. Transport anything.
I was told when I was going to make this session here that we must not do advertising for various products. This is an advertising movie, but it's difficult to find movies which are neutral on this topic here. There are many other suppliers doing the same thing as Mir is doing. I would say we are not great fans of pallets in our company. We would very much like to find a solution without the conventional pallets. To me, it looks like you have the pallet because you need the forklift to get in under your piles. They are trying to find a solution here to how to use conventional pallets. We would very much like to go in another direction and find some other kind of means for transportation instead of pallets, and we have something in mind. Here are no videos. No, but it's just to say here you have sheet cutters, you have folder gluers, folding machines, saddle stitchers, stitch liners, blah, blah, blah. All these machines are faster than the operators. So the operators, their lifting capacity is a human constraint to the productivity of these machines. Excuse me, to the capacity, production capacity of these machines. You can get the machines to run faster if you put more operators on them, especially the saddle stitchers and the collators and the stitch liners. But you don't get productivity, you get more production capacity, and what we want to get is productivity. So that means that if we can get rid of the human constraints in lifting capacity, which is a key topic for us, put on a robot, we can triple or quadruple the production capacity. Then, perhaps it's a little bit more philosophical here, but productivity, everybody talks about productivity. Question is, what is productivity? And in normal speaking, productivity is operator productivity. So then you must relate to input versus output. So if you can give the operator a tool which can make him produce more, you increase his productivity, that's very good. If the tool doesn't increase his productivity, don't invest in the tool. And again, adding more persons will not have any impact on productivity. Production islands. I don't think so many people think about this here, but it will also come. I will talk a little bit about Industry 4.0. But the same sketch as before, there are several production islands. And what we always hear is that why should we put a robot for 300,000 euro on a folding machine or sheet cutter to 150,000 euro? It doesn't make sense. But the printing press for 2 million, this machine we would like to robotize. And we are saying it has nothing to do with the machine price. The only calculation you have to do is how many persons are in the total production flow from entering the fresh paper to having the finished product in your hands. If you can take one person away, you will increase the productivity. And it doesn't matter where you find that person. And of course, there might be salary differences between the print press operator and the sheet cutter operator, but basically one person away increases the productivity. This is also a little bit philosophy, but it's very important things. We cannot say this in Danish. We have the same word for effectiveness and efficiency. But efficiency is to do things in the right way. Effectiveness is to doing the right thing. And perhaps I can explain a little thing I was discussing with a friend about this year the other day. And we said, efficiency is to find the best way to collect a cup of coffee from a coffee machine standing someplace away and back to your printing press or sheet cutter or whatever. So you are the less time away from your production island. But effectiveness is to eliminate that problem. So if you put a coffee machine next to the sheet cutter, you get much more out of it. We have to consider this a lot. The process, what is the best way to do the process when we configure the robot applications. But I would say, if you go into your own production now and consider what is the best way to do this here, there's a lot of profit in that if you examine your processes carefully. I can also, as a spin-off of this here, you will have operators doing the same task. One operator doing it one way, another way doing it another way. The third guy is doing it in the third way. And not all three versions can be the best one. So it's very good to examine your production processes to optimize your effectiveness, productivity. In Drupa 2016, Horizon introduced the very good slogan, finishing first. We think finishing first is very, very important. When we make robot applications, we always start with what is it we want to obtain, and then we work backwards. In the normal printing industry, I'm not so familiar with digital persons, but the offset guys, they always start with offset press. And this can give some very, very strange complications further down in the system. If you start your whole configuration, the press must be like that, and then everything else must be adapted to it. Always finishing first. A little bit about artificial intelligence. There will also be something linked up to Industry 4.0, but everybody talks artificial intelligence and the robot should run on artificial intelligence. And to me, artificial intelligence just now is expanded memory. And I don't know how many of you were present this morning for the Swedish gentleman's creativity explanation, but I have considered all the time that artificial intelligence in machines, it's not intelligence, it's expanded memory. And before I did this, the preparation for this seminar here, I started to look into what people write about artificial intelligence. And it turns out there's another statement out there called artificial general intelligence. And that is how humans thinking. So we can say now there's one intelligence for machines, which is memory, and one intelligence for persons, which is more than memory. Yeah? And well, some of these artificial intelligence guys are saying this is the ability to think or the ability to do creative thinking. And I think you are all familiar with Alexander the Great and his Gordic knot. And I am 100% convinced that no machine learning, no artificial intelligence would have come up with Alexander's solution of just cutting the knot. So I think there's a long way till we have something which can substitute human intelligence. What was this here? Yeah, this is a new statement from Forbes. And Strangely enough, artificial intelligence can read your sexual orientation by reading your head, your face. I didn't know that. Then you can you can beat chess games and all these kind of games that Watson is doing. But they're saying the computer configured for chess cannot do other plays and so on. You cannot do Jeopardy. And then they can do language translations. But again, the creative part of it, or the way to think, it cannot do. Industry 4.0, and I think it's a German statement or German concept here, but basically they want to link everything together. And we can just say it's a little bit back to the production islands. Today we are producing in different islands, but the future is that all these must be linked together. And my statement here is that you cannot link all the production islands in printing together in a computer system without having robots and mobile robots between the various units. As soon as you put a human in, you will have some dark areas which cannot be put into algorithms. Then, at the end of the day, Industry 4.0, linking everything together, all the islands together, you can only do that with an overall management system. And it's not your workflow systems telling your PDF and whatever going through. It's an overall management system. And I thought until yesterday afternoon when I walked around in the floor down there, I thought that the HP Print OS was such a system. But I learned yesterday by some of the computer people down on the floor that that's not 100% the truth. It's nearly the truth, but you have to add something else to it. And I can tell how many of you are familiar with Heidelberg? You're running Heidelberg presses? Prenect? Okay. 2 weeks ago, Heidelberg bought Keyline, a small system from a company in Mainz in Germany. And the story is that this is also an open system. It will be called High OS, and it's more or less equivalent of HP Print OS. And they are going to kill Prenect, they're saying, and run further on that. The objective from these guys, Heidelberg and perhaps also HP, is that all suppliers, that can be us, that could be MBO, that can be Agfa plates or whatever, can link into these overall systems. And then at the end of the day, you can control the buying of plates and inks and whatever over your central systems. Plus, of course, you can do an animation. Animation, it's not called like that. But you can pre-test your jobs in the system here, and they say, okay, it's best to run it on production line A, B, or C, and then you can check afterwards if it ran the way you expected it to run. Yeah, this is, I couldn't let, I'm doing a little bit of advertising for ourselves now, but this guy who unfortunately died the last year of cancer, he said one evening I visited the plant, your robot is God gives to sheet cutter operators because you have taken away all the heavy jobs for us. Yeah, thank you for your time, and I must say for me it was a pity we couldn't run the central videos from our side, but any questions? No? Okay. Anybody of you thinking about acquiring a robot in the future? Yeah, well, then I say thank you for your time.